All right, this is mud fossil transitioning from chicken tissue. And this was chicken tissue, and it was put in a soil with sand and, dirt, and electric current applied to it, just like you do when you plate a cheap ring. You do exactly the same way. Whatever it's in is called the electrolyte, and it plates whatever the electricity is applied to. And the same thing happens in creatures, and that's how body parts become stone in wet environments. And I'm going to show you the chemistry in a minute. But this I did, it took about, I don't know, 3 or 4 months, whatever. But this was a piece of chicken tissue, and now it's becoming fossilized. And this is what it does as it gases off the volatile things, the things that can vaporize out, and then you're left over with minerals and carbon and so forth. Now, out here, you see this? And I don't know if you can see it that well, but these are very tiny little strappy fibers, and they're the tendinous fibers. They're called fibrils, and they actually end up turning into a type of basalt that is not the type that comes from lava. This is what's called porphyritic limestone. It turns into, and it has fibers all in it. And it also turns into selenites and so forth, and it's extremely tough. It never erodes really, and the earth is made out of tons of it. And this is what some of it turns into. And I'm talking, there's giant creatures in the earth. That's just a fact. You don't have to get over that. Now, and that's from a giant creature. That's the same thing as that little piece of chicken tissue, but something big had it. And I did a lot of research on this. Let me see if there's anything. Okay, and this is the type of tendons that are a living tendon, and they have these strappy little things, and between the straps, the tendon straps, and inside that strap, there's thousands of fibrils, and you can see the end of these fibrils. I don't know if you can see any of this. It's a poor shot, and it's hard to see, but there's thousands of little tiny fibers inside these they turn into literal boards. Literally, they turn into boards. They're squared off, and there's angles everywhere. I mean, and they come in chunks, and that's what they built with in the ancient times, and that's just the way it is. And when I say giants, yes, absolutely gigantic giants. And if you look at the bottom lacy structure of this, there's blood. The red is blood. The whitish stuff is the limestone. Well, in your body, it's limestone. There is CaCO3. It's the calcium and phosphates and the minerals that create structure in bodies, that is strong stuff. The rest of the stuff is very weak, erodes away. But look at what it turns into in nature. And I said there's giants, and these are giants. That's that lacy stuff. This is the red that invests and nourishes the living tissue. And they show which one is younger. They're both the same age. This one was just carved up. And there's a ton of things in the earth that are holes in the earth that were made by vascular blood tubing. And they pump water out because the arteries open up. They're very, this stuff is very weak. It erodes away, and when it's in these tubes, sometimes they just blow right out of there, and you end up with plumbing. And these giant waterfalls off of mountains are from plumbing that was left over from giant creatures. And I'm sorry, that's just the way it is. Either you can look away from it and laugh, or you can investigate it and see if it's right or not. That's all I'm asking. By the way, this is mud fossil chemistry, and it's unimpeachable. Sandstone is silicon, virtually almost all silicon. Silicon dioxide comes from the fact that skin is dense with silicon, 50 times more than anything else in the body. It erodes away when it gets bonded with oxygens in the water, driven by the electrical currents, the telluric currents. And those bond with the oxygen, with the silicon, and it turns into quartzites, and they turn, that's sand, SiO2, sand, and that's what sandstone is, sand, and very little calcium in that business that's left over from the body parts. Mudstone is after the sand goes away, the skin, you end up with the flesh. Flesh is mudstone. These are the chemicals of mudstone: calcium, phosphates, and ferrous oxide, ferrous materials, and so forth. Then you get into the limestone, which is the connective tissue, and that's what it's collagen type 1 in the body. It's connective tissue, calcium and phosphates, and all of that sort of stuff. The mudstone contains blood and other tissues more heavily, but very, very, very similar to the limestone. But there's different concentrations here and there, but almost all the same stuff. It's unimpeachable chemistry, and the lab. I've done this in the lab, and I also made another fossil in the lab, and I'll show you that in a second. All right, this might be a little bit of a bumpy ride. This is the microscope I'm homing in on here. Now, this is a chicken bone, and this was, you see the black? That's the black of the ferrous materials that are in blood that's deep in the bone, and it's actually going to turn into garnets. Now, if you go back, you see now that was in the ground in this solution of moisture and so forth, like a mud fossil. Now I'm going down. You see that? That started to fossilize, and then there'll be other places that weren't in the. Let's see if I can find a place that wasn't in the fossil mix as much. Hold on. You can see that all of that stuff, well, it's pretty well fossilized. Well, hold on. All right, here we go. There's what the chicken tissue looks like, and you can see some of it in there is starting to take on fossilization. That's what happens. They grow in the void. See it? Now we're seeing something that makes sense. You see it there? The stuff that's growing inside those voids, that's not dirt or anything. That is actual mineralization of the tissues, which in this case are bone tissues. But this happens in flesh, and it happens in everything. I showed you the other ones that were flesh, but this is a bone. And now let's see down here. This one here, this part here is heavily mineralized. Hold on. I have trouble getting this thing focused in on it. This is pretty heavily mineralized down here. And you can see all those little black dots. Well, here's some that are open. You see they're open, but you can see the black dot way down inside there. They're going to end up pushing that stuff out to the top like these black dots. That is the process. And it will, these little dots are, you'll see them on a lot of different fossils, but it depends on the amount and the extent of the electric currents in the type of moisture. Was it, you know, what kind of ions were in the water? There's a lot of things to talk about, but that's how minerals invade tissues. Now, crazy as it seems, I believe this is a form of a bonehead from some giant creature, but I believe that's what it is. It's broken off over here, and the bone cap is up. This part is the bone cap, and that black is the they call it bone black, and it's internally in the bone heads because of the ferrous oxides. It's called a chemistry called ferritins, and this part, this is the oxygenated blood, and they mix together, and that's what powers your, well, you know, the oxygenated blood, the oxygen's used, and it's pumped back into the veins actually. Now, I also have something that, you know, I can give you some form of a demonstration here, but not much. This, as you can see, it's that type of affair where you have a bone cap, and then you have the striations in there. Now, I did show, I believe, that how the mineralization occurs, and it fills in all the little pores and things. Now, this had electricity running through it, in soils and sand, and I did a bunch of different ones. And they fossilize, they turn into fossils. So, and it doesn't take that long. So that's just the deal. Now, I would love to be able to see, and I believe this is the bone cap over here, and that cap surrounds the soft spongy tissue, they call it. Now, all these lines are very interesting and hard to explain. Normally I see these in tendinous materials. But I can't completely explain it, but it appears to be this is from a creature, and that you don't end up with just throwing black and red in the middle of everything. The only reason that occurs, and having red is iron oxides, and you look at this structure down in here, you can see that's the way bone invests itself. There's fibrils and fibers of bone and things like that, and in between it is the this dark stuff. Is really like the bloody component that's with internal in bones. So this, I believe, will be the same material that is found in fossilized bone caps, and I have some of those. And I believe this is mostly calcium, CaCO3, it'll have magnesium, aluminum, and all the different little metals of life. And that's what it looks like to me. All right, by the way, these are the colors of different, they call them metal complexes, and that's what I look at primarily for the blood. They get saved because of what they call chelation, and that's where metal complexes get surrounded and stored, and the DNA can come back out. But another thing I want to show you, is that you can add chemicals, different minerals into the solution of the what you call the electrolyte, and then like this has copper, but you could put vanadium, you could put strontium. There's all kind of different chemicals, red and yellows and all that, and that's what you see in the crystals as they start to form and invade, and they form literally little crystals, and they grow in the voids. So that's why you see all those different colors.